Next, let's look at how we might be able to use the 100% rule on the constraints side. That is, when we change the right-hand side, how can we use the 100% rule to predict, yeah, any impact, or what is the amount of impact on the optimal value. So right now, let's look at this problem here, right? So the question is this: if simultaneously the the amount, oh no, that's the range of optimality, but you look at this one. If the right hand side of constraint 2 is decreased by 25, the right hand side of constraint 3 is increased. So there's a kind of a interesting example. One constraint is decreased, another constraint is increased, right? So in business, it is possible that constraint 2 is the labor hours in division A, constraint 3 labor hour in division B. If we are going to shift the labor hours from division A to division B, then indeed we may have constraint 2 decreased by 25, constraint 3 increased by 25, the same amount. So shifting, to us in the business sense, shifting resource is like one action, right? But in the model, it is actually having two impact, two changes. One is the right hand side of one constraint being reduced. The other one is the right hand side of another constraint is being increased by the same amount. This is considered simultaneous change as well. The question is, can we make use of the shadow prices to predict the impact on the optimal value? Answer is, let's apply the 100% rule first. Yeah. So constraint 2 is decreased by 25. Current constraint of constraint 2, right hand side is 350. All right. And because we are talking about decrease, we need to look at the maximum allowable decrease as our 100%. Yeah. Common mistake for students, they add up the allowable increase and decrease, kind of like feeling right, but it's actually wrong. So if we are proposing to decrease, then the entire allowable decrease is our 100%, and we will divide 25 by 50. Okay, so currently 350. Let's just introduce a box here. So currently we have 350. We propose to increase by 25, and so the change is 25 out of a total of 50. Okay, so that, well, we don't have to draw the scale, but that's just to suggest the numbers. And we can straight away calculate the percentage. That's basically 50% of impact. So we have taken up a big chunk of the allowable shaking of the system. Yeah. And the other impact, the other change introduced into the system is the increase, right, in the right hand side. So let me get this straight. 375. So is the increase. No, sorry, down to. So 325, 350. Okay, so the change is reduced by 25, and therefore we need to yeah, so this is correct. So I just shift the graphics a little bit to make it right. Okay, now the other change is constraint 3. Currently it is at 600, and we are proposing to increase, and therefore the entire allowable increase, the 100, is our 100%. So that makes it easy because it's also 100. So currently 50. So currently 50, and we are proposing to increase to by 30. No, sorry, currently 600. We are proposing to increase to 630. Right. So the increase is 30 units, and the allowable increase is actually 100 units. Okay, again, it doesn't have to be to scale, but we just need to show that the 100% is larger than the amount of change. So this is easily 30%. Okay, so the now that we have garnered the total percentages, we can easily tell that this is less than 80%, less than 100%, and so our conclusion is that the guarantee still holds. What is the guarantee? Guarantee that the shadow prices are valid. The shadow prices will be the shadow prices that are involved in the changes. So the +4 and the -1 here, right? So the +4 and the -1. So what will be the impact on the optimal value? Because we have cleared the 100% rule, we can now say that we multiply the decrease by 25, right? So that will be -25 times +4, because shadow price is +4, plus the increase. So let's write this out more explicitly. Current objective function value is 800, right? So the change is given by the change in optimal value is given by a decrease of 25 times +4, because that's the shadow price, plus the increase by 30 units times the -1 shadow price here. So we put that in all numerically without concern as to whether it's better or for worse. Are we having more profits or more waste production? Doesn't matter for now, right? So all we care about is the change. And here we have -100 minus 30. So we have -130 change, numerical change. Now, since existing optimal value is 800, we will add to the existing value the change being induced. And so the answer is 670 units. All right. So this question, the M&D chemicals, is a minimization question, and therefore the lower the better. So originally it was 800 units of waste or undesirable output. Now it's 670. So that's an improvement. That's an improvement. You see that we can deal with plus changes here, minus changes there, and our percentages just pile up. Right? Another common mistake made by students will be whenever there's decrease, you have minus percentage. Whenever there's increase, you have plus percentage. And that's not quite right, yeah, because you might find that when you disturb the system 90% here and 90% on the other direction, you end up saying incorrectly that you have not made any disturbance on the system, right? That's not correct. So in this case, we find that any disturbance, plus or minus, is a disturbance, but still it is less than 100%. So we have cleared the 100% rule and we apply all the shadow prices because the guarantee still holds. And we just calculate strictly numerically, right, inclusive of all the signs of the changes and the signs due to the shadow prices as illustrated here. So this is a great example to alert us to be careful with the signs. So if you keep the signs intact and be very clear about all the pluses, because the values, the change pile up, right, and the plus minuses inside the brackets reflect the direction of change and the sign of the shadow price as given in the sensitivity report, then we get the correct final change amount. And we want to add onto the current optimal value the impact of the change amount, all right, including the negative sign. And that's how we correctly arrive at our final optimal value correctly the first time without making a mistake. So you will need a lot of that carefulness and clarity, you know, to get your exam or your quiz problems right quickly, because there's not much time usually, right? Okay, so we are done with the sensitivity report and simultaneous change analysis. Hope you have sort of clarified all the doubts in this topic, and see you in the next lesson.